Hey everyone, I'm Miss Feck and I teach chemistry at Heron High School.
Hi, I am Miss Gardner and I teach chem over at Riverside High School.
Hi, I'm Miss Foy, and I also teach chemistry at Riverside High School.
We have loved teaching you guys this year and are super bummed that things ended the way they did, but the three of us have all spent a lot of time in the kitchen just baking and cooking different things and trying new recipes, and hopefully you guys have done the same. And as chemistry teachers, we see chemistry all over as we're baking and as we're cooking, and hopefully you guys have started to see that as well. And we're just going to spend some time telling you guys today where we see cooking, where we see chemistry in cooking and baking in the kitchen.
All right, hope you enjoy.
In the beginning of the school year, back in the fall, we talked about physical changes and chemical changes, as well as physical properties and chemical properties. And one example of this is tonight I made salsa. So I had mangoes and lime and peppers and cilantro, and then made it into a salsa. And this is just a physical change because you could still take out every single ingredient. The chemical composition of it has not changed. I also made brownies, which this would be a chemical change because you can't, everything change its chemical disposition. There's chemical reactions that occurred. The baking powder reacted with different ingredients. You can't take the eggs out of this. Recently we talked about solutions and we talked about solutes and solvents. And one example of that would be if I was to make a lemonade. We have our solute, which is our what is going to be dissolved, which in this case is the Crystal Light lemonade packet, and then we have our solvent, which is our water. We mix it together and we have a solution. When we learned about acid and base reactions, we talked about baking soda and baking powder, and with baking soda, it reacts with an acid, which causes your cookies or different things to fluff up and do different things, whereas this baking powder has acid in it already with the baking soda. So these will have very different effects if you use the wrong one, which is why it's important to use one versus the other, as it will give you a different consistency in your baked product.
Hi students, welcome to Miss Gardner's Kitchen. So today we are going to be making vegan buttermilk pancakes. So if you don't already know this, I am a vegan. So how do I make buttermilk? Well, I just need some kind of non-dairy milk and a acid. Here I'm going to use apple cider vinegar and mix those together to make buttermilk. So buttermilk is essentially just milk that has curdled. Usually we don't want that, but sometimes we do for baking purposes. And so to hurry up this curdling process, I just need to lower the pH of my soy milk. And when that happens, the proteins in milk denature or unfold. And when they do that, they take on a different shape and then they can kind of clump together. So anyways, we're gonna cause that to happen by lowering the pH with my apple cider vinegar. So, all right, I've got my pH strips here. So let's test what our milk is before acid. All right, give that a moment. And that looks to have a pH of about 6. All right, so I'm gonna add in my apple cider vinegar. Put that in. Hopefully you can see some of this curdling happening. So do a little whisking. And maybe you can see this here. So it starts to kind of look like some kind of precipitate is forming around the edges here. So we'll leave that be for a moment. And then I'll work on getting the rest of my ingredients into the bowl. Okay, so I've let my apple cider vinegar and soy milk sit for a little while, and let me swirl around a little bit. So hopefully you can see there are some chunky precipitates or solids forming in the soy milk. So why would I even want to do this? It seems kind of gross, right? Well, actually, we're doing this because it's going to create an acidic environment that can react with our sodium bicarbonate that's in our baking powder and make even more CO2. So this gives those really nice, light, fluffy pancakes that hopefully we're going to get that look like this when we mix that together. So that's why buttermilk is often used in some kind of recipe. All right, and here is my final product. We've got some fluffy buttermilk pancakes with our homemade vegan buttermilk. All right, let me know if you give this a try.
Hello everybody and welcome. This is Miss Foy, and today we are in my kitchen to talk about how I see chemistry in the kitchen most often. So it is about 12:30 right now, and we are making a late lunch for my family. And what we are going to be making is turkey and cheese sandwiches is what everybody has decided upon what they want. And of course, no meal or meal prep would be complete without our lovely beggars here. This is Padawan, and I'm sure that the little one, Obi, will join us back here in just a moment. So there are 4 people in my family, if you do not know me. And today, if everybody wants to make and eat a turkey and cheese sandwich, I need to figure out how many turkey and cheese sandwiches I can make. Currently, this is the loaf of bread of what is left of it. This is how much turkey I have. And we are a pepper jack cheese family. But what we are going to talk about today is really our limiting reagent here, because we use this all the time in my kitchen as a family. If I count here for the number of bread pieces that I have, look, let's be honest, nobody really wants to eat the heel of the bread. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 slices of bread. I pre-counted the slices of turkey because it's a little bit more difficult to do that. I have 7 slices of turkey here. And in my pepper jack cheese, I only have left 3 slices of cheese. So in our family, typically when I'm making, I told you that our other smaller beggar would be back. They really love the turkey sandwiches. We like to make turkey and cheese sandwiches that have 2 slices of bread, 2 slices of turkey, and 1 slice of cheese. So if I have 11 slices of bread, I have 7 slices of turkey, and only 3 slices of cheese, how many turkey sandwiches can I really make here? Well, I can really only make 3 complete turkey sandwiches. And what is going to be, quote, my limiting reagent here? Well, it's going to be my pepper jack cheese. If I want 1 piece of cheese in every sandwich that I make, and I only have 3 slices of cheese left, I can only make 3 sandwiches. I would have about 3, I could make, if I didn't want 2 slices of turkey on each cheese, or on each one, I could break up the last piece of turkey. However, if I wanted to make a complete sandwich, I would also only be able to make 3 sandwiches with my turkey. However, I would have leftover bread. So this is going to be my excess reagent. So if there are 4 of us in our family, and all 4 of us want to eat turkey sandwiches today, we need to come up with some sort of alternative plan. So we use this all the time in my kitchen because when we are making food, we need to have a plan. Especially now in these kinds of times, we keep a food list of all of the potential meals that we could eat on any given day. And once that meal is gone, it has to be crossed off because I need to know that I need to go back to the store. Another thing about my family is that there are 4 of us, 2 of which are growing boys, and if you have brothers or you know boys, they eat a lot of food. So constantly when I'm cooking, I need to convert measurements in between to each other. So if a recipe typically calls for a teaspoon of something, likely whenever I am going to multiply that recipe, so I am doubling or tripling it, I am going to be using a tablespoon instead. So it's important for me to know that in every 1 tablespoon that there are 3 teaspoons. Or that if a recipe calls for a certain number of tablespoons, likely I am going to use a cup instead. And I need to know that there are 16 tablespoons that will fit inside of 1 cup. So we are constantly talking about our limiting reagents in our kitchen and also doing conversion factors frequently so that we know what food we can eat on any given day together as a family. So, I miss you all. I hope you all have a wonderful summer, and we'll talk more about where we see chemistry in our lives, and we look forward to seeing you in the fall. Bye.
All right, I hope you enjoyed seeing all those examples of chemistry in the kitchen, and your assignment for today is to complete the Google form that goes along with this video and to also do some chemistry in the kitchen yourself. So we want you to either cook or bake something today. Take a photo of it and write 5 complete sentences about how chemistry is involved in that process. So you can be talking about any of the things that we talked about in this video here. and just explore how chemistry makes all these amazing things happen.
If you are unable to cook or bake something today in the kitchen, that is also okay. There is also an alternate assignment posted in today's assignment. So if you're not able to get into the kitchen today, go ahead and check that out as well.
We hope you all have wonderful summers. We miss you all dearly. Make sure if you have missing work, you complete that by the deadline, and make sure next year you come say hi to us in the hallway. We're excited to see your faces again.
All right, bye for now, scholars.